Hi everyone, my name is Saurabh Pant and I am today continuing with my Rank Booster series. So in this series we are going to discuss in today's lecture the atoms in the same plane. How many atoms are there in the same plane? Looks like an easy topic, but this topic is not available in any of the book directly. So what we have to do, understand there are two things. One, organic chemistry questions are there which are based upon alkynes, alkenes and alkanes also. Alkanes questions are usually not asked, they are simpler also. Mostly they ask the questions on alkynes and alkenes, ki how many atoms are there in the same plane. In alkenes also, one we will discuss about the conjugated as well as cumulative alkenes. Both are there. Next, in the inorganic chemistry the questions are very common. You will find a lot of questions even if you don't read the lecture I am giving you right now also. If you are good in the hybridization aspect, you will be able to do that. But in this video, my objective is to boost up your rank, and that will happen only when we will discuss the topics which are in two different subjects. I'm considering organic and inorganic as two different subjects, but the questions and the concepts are common. So if any question comes from anywhere, you will be able to crack it down. Now, there are many ways of dealing with this. I can start with random examples. Example regarding the structural similarity, like linear structure I can discuss first, then the planar structures I can discuss. But I would prefer something which will help you in two ways. So I'm preferring with the hybridization. I will go hybridization to hybridization, from SP to SP2 to SP3 and so on. Two things will get covered in this. One is the topic which we are covering. Secondly, how to draw the structure will also side by side get covered. So it will be very beneficial for you to see this video till the last. So let's carry on. Starting from the first hybridization, that is SP hybridization. So in last video, I've already told you, I think 3-4 videos back, how to find the hybridization using a trick. So let's say the example is CO2. So SP hybridization is always going to be linear in shape. So CO2 is one example, C double bond O, double bond O. So it is linear. It is linear. So all atoms, whichever is linear, all atoms are in the same plane. So bhaiya, all in same plane. What does it mean? How many atoms in the same plane? Total 3 atoms are there in the same plane. SP is pretty simple. In short, linear, all are in the same plane. Second, SP2. SP2 is also simple because the name itself is trigonal planar yaar. Kyun bhai? Trigonal planar means what? They all will be in the same plane. For example, BF3. In BF3, all the atoms are in the same plane. So understand, in this structure, BF3, all atoms are in the same plane. So atoms in same plane. Now here people do a very small careless error. They calculate F. All the 3F are in the same plane and they write the answer as 3, whereas the answer is 4, which is a very simple common sense idea that central atom also you have to consider here. So central atom is also in the same plane, 3 fluorine are also in the same plane, so total 4. Here also carbon, oxygen, all 3 are in the same plane. People miss out the central atom while calculating the atoms in the same plane. That is the first common error that usually happens for the NEET aspirants especially. Why not JEE Main I am saying? Because in JEE Main question goes a little to the higher side and there this error is there, plus they are not able to identify the plane also to consider. So whenever the question comes atom in the same plane, they are indirectly asking you maximum only. If they mention maximum, very good. If they don't mention maximum, then also you have to consider the maximum atoms coming in the same plane. Chaliye bhai, going ahead. Number 3, from here the nice part will start. But before going here, let's understand one very important thing. BF3, badhiya. BCl3, बहुत बढ़िया. BBr3, BI3, all are trigonal planar. But when we talk about BH3, BH3 does not exist as BH3. It exists as B2H6, that is diborane. So when you say diborane, it is one BHHH, another BHHH. There are two BH3s. They come together and this hydrogen will try to share this bond with 2 of the borons, and this kind of a bond you might have known is called 3 center 2 electron bond. There is a whole topic, boron family, discussed in the playlist already. Now, how many bonds can you see this boron is making? So 1, 2, 3, 4 bonds are there. So hybridization for the NEET and JEE examination is going to be SP3. Sir, why you are saying the hybridization for NEET and JEE, otherwise hybridization is not SP3? No, when you go to the higher classes you will understand perfect SP3 hybridization does not come. Something known as hybridization index is there, which is completely irrelevant for the NEET and JEE examination. If you learn that thing, you might lose marks. So for us, if there are 4 bonds, SP3. So boron in both cases are going to be SP3 hybridized. Now, when SP3 comes, you cannot apply this logic. You cannot say all the atoms are in the same plane. So understand the idea here. So for SP3, what to do? देखो भैया, for SP3, remember how the SP3 get made. How do you get SP3 structure? is देखें, you have let's say a carbon. I'm starting from something you already know, carbon. let's say it contains one hydrogen here, second hydrogen, third and fourth, and this is called tetrahedral. This is called tetrahedral structure. In the tetrahedral structure, what you already know in organic chemistry, you might have seen that these two atoms are written as lines only, and one of them is given a wedge and one of them is given a dash. One of them is given a wedge and one of them is given a dash. This wedge means above the plane and this dash means below the plane. That means there is a carbon here, there is a hydrogen here, there is a hydrogen here. One H is projecting outwards like this and the other H is going backward below the plane of the board. So bhaiya, clear cut, this kind of a structure is not completely planar, but this atom, these two lie in the same plane along with the central atom also. So how many atoms are there in the same plane? So atoms in same plane right now are 3. So one is the central atom and 2 of the terminal atoms. So just remember, in the case of tetrahedral, there are 4 bonds, out of which 2 of them, any 2. So this 2, if there are hydrogen, chlorine, fluorine, bromine, then which 2 we have to consider? Any 2 here. If any 2 you consider in the same plane, the other 2 will go in the other plane. That means if I have carbon, fluorine, chlorine, bromine, iodine, so if I want to consider fluorine, chlorine in the same same plane with carbon, then iodine, bromine will go in wedge dash. If I consider chlorine, bromine in the same plane, the other 2 will go in the wedge dash. If bromine, iodine are in the same plane with carbon, then bhaiya fluorine, chlorine will go in the other plane. So we have to understand this idea कि any 2 we can consider in the same plane. So basically every pair is in one of the plane. Sir, what does it mean? So देखो यार, understand the idea. To understand this idea of sp3 hybridization, you have to be very clear cut in how the sp3 hybridization looks like. Then we'll come to this B2S6 example also. So देखिए यार, how the sp3 hybridization comes, because it's a very abnormal angle यार. 109.5 degree angle comes. Why? तो देखिए यार, this can be projected in a cube. This can be projected in a cube. So देखो यार, what happens here? So there is a central atom here. ठीक है? So what happens? How the structure of hybridization comes into play? देखिए भाई, try to understand this. So when there is a central atom here, let's say this is the carbon here. One of the hydrogen you can go give to one of the corner. This corner is one hydrogen. So when you get this hydrogen here, then the adjacent corners are cut. Here, here, here. You can understand that? From here, one adjacent corner, second adjacent corner, third adjacent corner is cut. So these adjacent corners, the next hydrogen cannot come. ठीक है भाई? Then what to do? Next hydrogen can come here, because you can see this is not the adjacent corner. Now from this also, this one cut, this edge cut, this edge cut, and from here also this edge will cut. So basically the 2 hydrogens or the 2 terminal atoms are not going to come on the same edge. So you have to cut those edge. Those positions are not allowed in the case of a tetrahedral. Then next what? Next sir, this position seems to be empty. बहुत बढ़िया. Then here cut already there. Here cut already there. Here cut already there. So these 3 positions not allowed, and already we have cut them. So the last position is this. So if you make the structure from here, what do we get? If you make a proper structure from here, तो भैया, this is one of the bond, second, third and fourth, and this is how your tetrahedral actually looks like. So this is how your tetrahedral is looking like. So I think you can visualize it more easily now. I think you'll be able to visualize it. Just hold this bond, and bring it out. You will understand it's a very nicely made tetrahedral structure. Very nicely made tetrahedral structure is there. So understand what happens. If I choose any one of the plane, so I'm choosing one side plane. Let's say this plane I'm choosing. So if I choose this plane, so you can understand sphere number 1, 2, 3, 4 I'm making. So in this 1, 2 and 3, 4, on this shaded plane, on this side of the wall, 1 and 2 are coming. ठीक है भाई साहब. Similarly, if I choose some other plane, let's say I shade some portion on the top, I can shade. Let's say this one I'm shading with red. So if you see this top plane, so this 1 and 4 are coming in this plane. Similarly, in this side plane, 3 and 4 are coming in the diagonal in this side plane. At the bottom plane, 3 and 2 are coming in the diagonal. At the back plane, that means this plane I'm talking about. You can see clearly bhaiya. On this plane, which 2 atoms came here? So on this plane, atom number 3 and atom number 1 are coming at the back plane. So you can understand, whichever the plane you choose, one pair of terminal atom will come there and remaining 2 will be from some other plane. So whenever we count the number of atoms in the same plane, so remember 2 of them are in the same plane and one of them will be dash, one of them will be wedge. So which one wedge, which one dash? Any one of them you can take as the wedge, any one of them you can take as the dash. So here how many atoms in the same plane? Here also there are 3 atoms in the same plane. चलिए बहुत बढ़िया sp3. I think you also understood कि why sp3 angle comes 109.5 degree, because this angle you can think in this way कि this is the square and one atom is hanging on the top here, and from here 2 bonds are going like this. So this angle will come from the extrapolation here. So that angle comes out to be mathematically 109.5 degree. तो बहुत बढ़िया concept this is. Now let's carry on. So in the case of sp3, this is the scenario. So we have to be very careful with the sp3 part only. If this part you get clearly, remaining to bhaiya becomes very easy halwa for you to eat very easily. Chaliye, so let's see more examples from here. So from here, I have to enter into the B2S6 example here. B2S6 example I'm entering into. So let's see the B2S6 example. So we have B, H, 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 B, H, 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 H. So sir, which 2 atoms you will take in the same plane? I will take the atom whichever are easier for me to take in the same plane. So I am taking this atom and this atom in the same plane. That means sir, one of them wedge, one of them dash. Yes, the other hydrogen, one of them wedge, one of them dash. Don't consider anything else. Just consider this boron. Leave that one. Because this is also sp3. Sir, how can we say sp3? 4 bonds, sp3. Khatam. No lone pair and 4 bonds, sp3. This one is also sp3, but this I will consider later. So what happened? These 2 I considered in the same plane. These 2. Any 2 terminal atoms I can consider, so I considered these 2. The other 2 wedge and dash. Now if this is the wedge one, this automatically becomes the wedge one. And if this is the dash one, this automatically becomes the dash one. Then what happens? These 2 go above the plane, below the plane. That means this hydrogen is coming like this. And the other hydrogen at the back of the plane. So something like this kind of a structure is there. There are 2 borons here and 1 H going above the plane. Let's say this is the plane. 1 H above the plane here, 1 H below the plane here. Then what happens? If these 2 are wedge and dash, then other 2 will be in the same plane. So these 2 come in the same plane. So how many atoms are there in the same plane? So maximum atoms in same plane. What I got here, very beautifully you can understand कि sir 1 2 3 4 5 6. So 6 atoms are coming in the same plane. How I got it? Because this was sp3. There were 4 bonds around it. 2 of them I considered in the same plane. Sir, if I consider these 2 hydrogen in the same plane, will the answer be wrong? Answer will not be wrong, but you will not get the maximum atoms in the same plane. You want maximum atoms in the same plane. For that, it is better to consider both if you want to. But I'm telling you, you will get this 2 hydrogen in the same plane. You will get the answer more easily. So what do we get? 2 hydrogen in the same plane, 1 wedge, 1 dash. Here also 2 hydrogen in the same plane, this wedge, this dash. So clear cut, these 2 are above the plane, below the plane, like a banana bond, 1 banana front, 1 banana back. And there are 3 and 3 total 6 atoms in the same plane. Let's enter into some more complicated examples from the organic chemistry part. So भैया next example I'm putting on the board is HC triple bond CH. So देखिए यार, this carbon is also sp hybridized, this carbon is also sp hybridized, and we know sp means linear. So if this is linear, then all the atoms are in the same plane. So total atoms in the same plane are how many? 4. Now, increasing the level of the example, let us take CH3C triple bond CH. Badhiya? So let's continue. So CH3C triple bond CH, firstly write their hybridization. So this is sp, this is sp, and this is sp3. We just worry about the central atom, not these hydrogens. They will adjust because we know the technique. Ab dekho what to do. C triple bond CH. So this lie in the same plane, this lie in the same plane, this lie in the same plane, and here also whichever the atom comes here lie in the same plane. Because already we have seen for both the sp hybridized carbon, whichever the 2 atoms connected to it are. Because sp hybridization is there, they are connected to each other. So one atom more will be connected here. So if these 2 are in the same plane, so one atom, this one and this one will also be in the same plane. In fact, they all 4 will be linear also. All 4 will be linear also. In the same way, from here you can take the hint ki what I am doing here. Now what happens? This carbon I have marked as sp3. So when I say sp3, 2 bonds, 2 atoms nahi, 2 bonds keep in mind. atoms also, bonds also are same, but if you keep bonds in mind, it will become much easier for you. So two bonds keep in the same plane, two bonds in the same plane, and one wedge, one dash. तो अब देखो, for this carbon here, already one bond I can see here. So only one more I can keep in the same plane. There are 3 hydrogen. So one I keep in the same plane, one I put wedge, one I put dash. चमका भाई. Sir, why did you take this one in the same plane? अरे भैया, I am finding maximum number of atom in the same plane. Already ready-made 3 atoms I am getting in the same plane, complementary. I will take this one only in the same plane, because to get maximum number of atoms in the same plane. So for this carbon, it was sp3 hybridized, 2 atoms in the same plane, one above, one below the plane. So count now total number of atoms in the same plane. खत्म हो गया. 1, 2, 3, 4, 5 came atoms in the same plane. ठीक है भाई साहब. One more देखें यार, one more example you can see. We can take example of CH3, CH, double bond CH2. Now when we write double bond CH2, we understand कि भैया here, or let's say for a change, I am writing here one H. Let's make it complicated. CH, CH3. बढ़िया यार. तो CH3, CH double bond, CH single bond, CH3. Very awesome example this will become, and you'll be able to understand much more easier. If you get this example, all the example will become halwa for you of this type of questions. तो देखें. So this is sp3 uncle, this is sp2 uncle, this is sp2 uncle, this is sp3 uncle. Now sp2 uncle are lying on the same plane, to understand that here. So this carbon and this carbon, these two lie in the same plane, so circle them, they are in the same plane. Acha, in the sp2 hybridization, take the example of BF3, you will understand the idea more easily. In the case of BF3, this was sp2 hybridization. How many atoms are in the same plane? All the 4 atoms are in the same plane. So terminal atom number 1, 2, 3. So there are 3 bonds and all 3 in the same plane. So bhaiya, C double bond C, and it is connected to hydrogen and methyl. So hydrogen, methyl, hydrogen, methyl. Now some people do this thing that this is in the same plane. Bakwas. Why bakwas? Because atom is hydrogen, This CH3 is a group. Who is the atom? Carbon is the atom. Who is the atom? Carbon is the atom. So he is also in the same plane. Chamka bhaiya kya hua? So this is also, forget this, this is also like BF3. So this atom in the same plane, this atom, and here this atom in the same plane. Similarly, this atom in the same plane, this also in the same plane, just like BF3. Think this is the B here, F. So here in the same way F. So you can understand these all atoms are in the same plane. Now this was sp2, बहुत बढ़िया trigonal planar example we have got, but this was sp3, and with sp3 already we have practiced कि one bond तो भैया this one I will take in the same plane, one more bond I am allowed to take in the same plane, तो भैया one hydrogen will come here and one wedge, one dash. Similarly, one hydrogen in the same plane I can take, one wedge, one dash. So how many atoms in the same plane came? These two also came in the same plane. Why? I can take 2 bonds in the same plane. So if this one I have taken in the same plane, one more hydrogen I can take in the same plane. Other 2 will go above and below the plane in sp3 hybridization. So how many atoms in the same plane? 1, 2, 3, 4, 5, 6, 7, 8 atoms you got in the same plane. Beautiful, lovely question here. Chaliye, let's level up. Are you able to digest? I guess you'll be able to digest this thing up to here. If not, you can revise and check here. Achha, one more feature is there. You might be knowing it or not. In the YouTube, I was trying to tell it. I always forget. So I'm just taking a small tangent. In YouTube, there is a feature you can 1.5 times or 2 times the speed. 1.75 times also you can do the speed. So maybe when the teacher is explaining slower, any video that you see, you want to see it faster, you are already good in the topic, then you can just increase the speed of the lecture going on. The voice quality will change, but the content you will be able to understand. It will be helpful for you. Let us see. Next, I am taking the example of allenes now. What are allenes? They are cumulative enes. Cumulative enes means carbon, double bond, this kind of thing. So double bond back to back. So how many atoms are there in the same plane? They are asking here. One more question they can ask you in the same type, that we will also discuss, but right now understand how to do this kind of a question. देखिए भाई, very beautiful theory and very, very important part also. तो देखिए, one more example I am taking, C double bond C double bond C double bond C. This question becomes very important in the optical as well as geometrical isomerism also. Those who know this topic, they will understand कि हाँ sir, 100% we have read this topic there as well. तो देखो what to do. When we have sp2 hybridization, whenever we have sp2 hybridization, there are 3 p orbitals, px, py, pz are there, out of which you have to choose two of them. If you choose s, px, py, then bhaiya XY plane. Because trigonal planar, then which plane planar? There are three planes, XY plane, YZ plane, ZX plane. So XY, YZ, ZX. Three planes are there. There are three walls you can get here. So XY, YZ, ZX plane are there. Which one plane are you talking about? So if I take in the SP2 PX, PY, then bhaiya XY plane. If I talk about S, PY, PZ, then YZ plane. If I talk about S, PX, PZ, then bhaiya XZ plane. So you have to understand there are three cases of planes possible. अब देखिए ब्यूटी ऑफ द क्वेश्चन. हाइब्रिडाइजेशन sp2, हाइब्रिडाइजेशन sp, हाइब्रिडाइजेशन sp2. तो देखो यार sp तो लीनियर, sp is linear, so he is not going to decide anything. So these three atoms are in the same line, they are linear, they are in the same line. So here is not the problem. The problem is in this sp2. तो ये भी तो sp2, ये भी तो sp2. Sir, all the atoms lie in the same plane? नहीं. Listen carefully, when double bond comes one after the other, what happens? Very beautiful example is there. So sp2, which p you can choose? Any, your choice. XY, YZ, ZX, any one of them you can choose. Either you can choose PX, PY, or PY, PZ, or PZ, PX. So I am choosing for simplicity SPX, PY. So let's say this sp2 is SPX, PY. Because there are three p orbitals, I need two of them I can choose. So that means which plane is this one? So this plane becomes XY plane. This plane becomes XY plane. So this hydrogen, these are coming in the XY plane. But yeah, understand, I should write it in the square. Understand कि भैया carbon is in the same line. These two hydrogen are in this XY plane. So there is a line going on, and from this line XY plane hydrogens are coming. There are two hydrogens coming at the XY plane. बहुत बढ़िया. अब देखो, if XY plane has come here, sp2 hybridization has come here, understand pi bond is not formed by hybrid orbitals. So hybrid orbitals do not prefer to form the pi bond. There is one exception, benzene is the exception, none of our concern right now. But understand, pi bond is not formed by the hybrid orbital, it is formed by the pure p or pure d orbital. And because all are carbons here, so pure p orbital will be forming the pi bond, pure p. Ab batao, if you took px, py for sigma bond formation, hybridization means sigma bond. Hybridization means either lone pair or sigma bond. Pi bond cannot be made by the hybrid orbital. So if px, py you have taken for the sigma bond formation, then who will form the pi bond? Sir, px, py, pz are there. Sir, xy uncle has gone for sigma bond formation. Then sir, pz orbital will form the pi bond. Acha, if this is giving the pz orbital for pi bond formation, then this will also give a pz orbital for the pi bond formation. Why, sir? Because pi bond is sidewise overlapping. So orbital should be parallel. So if this gave pz, he will also give pz. Acha, think about it. How many pi bond this carbon number 2 is forming? Carbon number 1 done, over. Carbon number 2, let's talk about him. Sir, he is forming 2 pi bond, one here and one here. Very beautiful. One bond here, one bond here. Very nice, beautiful example is there. So bhaiya, if I am carbon, I have to make 2 pi bonds. I need 2 pure p orbital. 2 pure p orbital. Do I have it? 100% I have. Why? I am sp hybridized. There are 3 p orbitals available, and for hybridization I need one of them. So remaining 2 will be unhybrid. But I gave my pz orbital for making a pi bond here. That means the other one I will give it there. The other one I will give it here, there. So you can decide any one of them. Ki let's say this is the px here. Px here. Sir, can I write pz here? No, pz you can't write. Why? Because pz is making the pi bond. So if pz is making the pi bond, here the pz is not allowed to be there because pz is required for making the pi bond here. Then what you have to do here, you will get a py here. Sir, why py? Because px is making the internuclear axis. Pz is making the pi bond. Py on the left side. Py is the only orbital left to make a pi bond on the right side, and this carbon will make a pi bond here. So if he is giving the py orbital, he will also have to give the py orbital for the pi bond formation. बहुत बढ़िया. अब बताएं यार, in this sp2 hybrid orbital, you have sp, pp, 3p available. 2 you have to take. Which 2 are available? Sir, py is making the pi bond. So sir, py is not available. So sir, px and pz is available, sir. And if the px and pz are available, then sir, these people are lying in the xz plane. अच्छा जी, the khichdi is saying कि this is the xy plane, this is the xz plane. So if these two hydrogen are in the xy plane, then these two triangular hydrogen are in the xz plane. मतलब ये कि if this is wedge, then this is dash. क्या बात कर रहे हो सर? बिल्कुल सही बात कर रहा हूं यार. ठीक है भैया. So what happens? How many atoms come in the same plane? 1, 2, 3, 4, 5 atoms came in the same plane. Maximum only 5 atoms. Let's understand the example. I will explain you one more example. This one you'll be able to digest this much better. चलिए, let's see. देखिए भाई, in this example, so one more is required. In this example now, let us understand what the scenario is. Very simple. Choose the internuclear axis. I am choosing z axis as the internuclear axis. So if I choose Z here, then how many orbitals are available for the pi bond formation? So bhaiya X and Y are available. So here this one I get S, sorry, not X, Y are available. Z is making the internuclear axis, means Z you have to use here. So the other one you can use PY. So let's say I took SP2 as SPZ PY. Sir, why PZ PY? Arey bhai, just for change, kya dikkat hai? Just for change I used Z is the internuclear axis. What was the internuclear axis here? X was there. So understand SPZ PY. So now let's say PX pi bond formation. If PX used here, for the next bond PY I can use. Acha, remember PZ pi bond formation not allowed. Why? Because it is an internuclear axis. Internuclear axis means sigma bond will be formed along it. Sigma bond will be formed along it. Pi bond not allowed. Sir, I can use Y also. How you can use Y also? Then here only PX will come. PX will come, PZ will come, PZ will come. So if I'm choosing Z as the internuclear axis, PX came here, PY came here. Acha, this carbon gave PY here, so to make the next pi bond, he will have to give some other orbital, so he will give PX. Sir, can he give PZ? As I said, PZ cannot be given for the pi bond formation now here. Why? Because Z I have chosen as the internuclear axis, so he will give a PX. So understand? He gave PX. It's up to you to choose. You can do one more time this kind of question also. Same question you can do here. I choose PX here, so he will give PX here. Trick is very simple. If this carbon gave PX here, so he will give PY here, he will give PY here. So that means if PX used here, so SPY PZ left here. If PY used here for this carbon, SPX PZ left here. Because there are 3 PX, PY, PZ. If I use PX for making the pi bond, then PY PZ will be left over. So SP2 will be PY PZ and the plane will become YZ plane. If I use PY for the pi bond formation, then bhaiya PX PZ will be left here. So XZ will be the plane we are talking about and SP2 hybridization will come. In the same way, in the exactly same way what we have done here, in the exactly same way we have taken PX here, so he will give PX for the pi bond formation. This carbon gave PX on the left side, so PY he will give on the right side. This carbon has to give PY for making the pi bond. Because this carbon gave PY here, so he will have to give the PX orbital here. So PX to already came here na. This PX was of this carbon. This PX is of this carbon. Kya dikkat hai? Every carbon will have one PX, every carbon will have one PY. Similarly, you come here, he is giving a PX orbital, so he will also have to give the PX orbital, then only the pi bond formation is possible. Ab dekhe yaar, which plane you will get? Sir, PX is given by this carbon for this pi bond formation. So sir, YZ orbital left. So sir, SPY PZ. ठीक है भाई? Now, this was also SPY PZ. This is also SPY PZ. So this is also in the YZ plane and this is also in the YZ plane. That means this hydrogen, this hydrogen, this hydrogen, this hydrogen, all these 4 hydrogens are in the same plane. These all atoms were anyway linear, so everyone in the same plane. So in such a situation, everyone in same plane. So in such a situation, what we get? 1, 2, 3, 4, 5, 6, 7, 8. So bhaiya 8 atoms in the same plane. So 1, 2, 3, 4, 5, 6, 7, 8. Understand now? Trick. This was the logic. So logic is very good for the understanding part. But in the exam, this much you will not do na yaar. So understand the logic. Trick is that for allenes means C double bond, C double bond, C double bond, C and so on. This kind of situation. If you have even pi bonds and if you have odd pi bonds, so bhaiya trick will very easily work yaar. If you have the even pi bonds, let's say C double bond, C, this kind of a situation is there. Here you have some X atom, here Y atom, here Z atom, here P atom. So bhaiya XY and ZP, these people will be in the different plane. This will be different plane. this will be different plane. So for E1, the plane will be different. Already we have done. For the odd bonds, you can see here how many bonds were there? 1, 2, 3. 1, 2, 3 means if there are odd number of bonds, then this XY, this PQ, they are in the same plane. So bhaiya, what we can do? Simply you can understand that all the atoms will be in the same plane. So देखो यार, after getting this trick, the question becomes pretty simple for you. How it can become pretty simple for you? You can understand this example यार. Very simple example you can understand. देखो, I'm just randomly writing the number C double bond, 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 C. Hydrogen here, fluorine here, chlorine here. तो बताओ भैया, how many atoms in the same plane? तो sir, 1, 2, 3, 4, 5. Sir, odd number of pi bonds coming. So odd number means fluorine, chlorine, hydrogen, same plane. Sir, they are already linear. So they will be in the same plane only. So sir, 1, 2, 3, 4, 5, 6 atoms in the same plane plus 7, 8, 9, 10. Sir, 10 atoms are coming in the same plane. So understand the trick is pretty simple. Even pi bond, back-to-back pi bond has to come. Don't apply this here. This is a different scenario. Here you will have to find the method which I have told previously, which I just now removed from the board. So you have to write sp2, sp2, sp3, sp3, sp2, sp2, sp3, sp2, sp2, and then you have to carry on. But here, in the case of allene, to clear cut, you will get which atoms are in the same plane. If the even number of pi bonds are there back to back, then bhaiya, corner atoms, these two are in the same plane, these two are in the same plane, but these two are not in the same plane as these two. Let's say if this is an xy plane, then this must be yz plane, something like this. So if these two are like this in the same plane, let's say, then these two will be something like this in the same plane. Okay, bhaiya? So these two atoms and these two atoms are not in the same plane. In the same way, when odd pi bonds are there, in the case of odd pi bonds, these corner atoms are coming in the same plane. So bhaiya, we have increased the level to extreme height. Now let us come back to the ground level and get the new idea. So I think it was a little of the higher level for some of you, maybe most of you, I don't know. But if you understood it well, good for you. If you didn't understand, I told you the trick. But I can't remove this topic from the syllabus. I did not decide the syllabus. If it is tough or easy, that is not in my hand. My job is just to explain whatever comes the way.